This is such a pretty problem. We've got complex trigonometry to talk about in a visual sense now. I really want you to understand the concepts geometrically of what's happening as you take roots of complex numbers. That's what this problem is all about. And I've got the root theorem up here from De Moivre that we're going to be using. And there's three parts to this question: square roots, cube roots, and fourth roots. Okay, so that means this n value is going to be either n equals 2 for a square root, or 3 or 4 for the cube roots, and fourth roots. We'll get to those. And what we're going to do is we take all these numbers, which are on the unit circle, meaning they all have a modulus of 1, and that's helpful. We're going to be taking square roots of them and cube roots of them and so on. So we'll start off with a. Where is a? That's right here. So if I take the square root of that, I should be able to find its location in some of these other points around the circle. And here's why. The modulus of a is 1. That means the square root of 1 is going to be 1. It will have the same modulus. It will be on the same circle. The question is, where's the angle? So what's the angle of a? You should be getting something like this as you look at it. I don't think this is too hard. 0 degrees, right? Or 0 radians, however you want to think about it. Well, what we have to do with De Moivre's theorem is divide that by 2. So what's 0 divided by 2? That means a is its own square root, which makes sense if you think about it. What's the square root of 1? Well, it's 1. Okay, next. So how about we take a look at the other part of this theorem, the plus 2 pi k over n part. Well, 2 pi times 1, remember k equals 1. Here, I'll be more clear. For square roots, these are your roots, w0, w1. For the second root that I'm going to be looking for here, k equals 1. So that makes 2 pi over 2, which is just 1 pi. So what is 0 plus pi? Right, it's just pi. So that lands us over here at m, the second location. And that's it, we're done. Now, let's move on to cube roots. Okay, so for cube roots, I'll do these in blue. In cube roots, we're going to be setting n equal to 3. All right, that's the third root over here, and all the n's go to 3. Well, what's the third root of 1? Right, it's just going to be 1. So we know it's still going to be somewhere on this unit circle. The question is, I need to first divide 0 degrees by 3. Well, that lands me at the same position, a again. It's kind of funny. And then as you add portions to it, we're adding portions of 2 pi over 3. So the first portion of 2 pi over 3 is going to land me here at I. And the second portion of 2 pi over 3 is going to land me here at Q. All right? So, okay. I misread the problem. I was taking the cube roots of A. Sorry about that, but you see how it works with finding angles. I guess you'll have to do J on your own. Let's do this last part. Do this last part here. What is the fourth root of the complex number Q? Okay, so first, let's go ahead and actually find Q this time. Boop, 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 boop. Here we go. There's Q. So what is its angle? It's at 240 degrees. So the first thing we do is we're going to divide that by n. And what is n for this problem? Well, when you're doing fourth roots, n is 4. Okay, so first thing we're going to do is divide theta by 4. So 240 divided by 4 is 60. Find 60 degrees. Here we go. That's our first root. And now each successive root is going to add how much to it? Well, 2 pi k over 4. K is just going to be 0, 1, 2, 3, 4. So we're really just adding 2 pi over 4 to each one. That means pi over 2, which is 90 degrees. So first root goes 90 degrees this way. Hello, k. Second root, another 90 degrees. And we get to Q again. It's interesting. And the fourth root is going to go another 90 degrees. And I feel like I'm off. Oh, this arrow is too small. Watch those arrows. The next root is going to go 90 degrees to W. We have this beautiful symmetry that is set up with these points around the unit circle as we take roots.